And this song we're going to sing this morning, and you can follow along the words on page 100 in the hymnal if you desire. But it's a hymn of joy, because in an increasingly troubled world, great is God's faithfulness.
Now, in reading this text, what we need to do is, if you have a Bible in a different language, if you read other than the King James Version, the New King James Version, which I'm going to read from now, we'll get a better understanding of the text. So, Isaiah, as they say in England, Isaiah 55:9. For as the heavens are higher than the earth, so are my ways higher than your ways, and my thoughts than your thoughts. Thank you.
It was working at 9 o'clock.
There we go.
Yay! Intelligent design.
Unintelligent user.
Well, it's a good thing. I decided to change the title slightly. I gave this talk before and I called it just The Creator. And then they put the title out on the marquee and it said, Dr. Pittman, the Creator. And someone comes up to me and says, isn't doctor good enough for you? Now you're the Creator. So now I've said I'll clarify it a little bit. So I did mention to my wife that I created Wesley, and she's like, hardly. So, had very little to do with it. So this talk basically is a series. It's a series of 3 talks about God, the creator of the universe, and then it's going to be God, the creator of life, and then finally God, the creator of time. So this first one is about the universe, and this is a very special place that we live in, and this just a few of the highlights. It's a lot more special than what I'm going to present today, but just a few things to give you a taste. Before we start off, though, the Bible makes some extraordinary claims about the fundamental questions of life, what everybody wants to know. Who or what made everything, and why are we here? And the Bible says that it knows the answer to these questions, and it says basically God made everything, and that God made us in order to please Him, right? But are these claims of the Bible trustworthy? I mean, they're pretty fantastic claims, what the Bible says. And do they make logical sense from a rational basis, or are we just supposed to have blind faith and believe the Bible, whatever it says, or is there some evidence for it? Is there a reason to believe for why we're here today? And can we recognize, basically, in this particular discussion, can we recognize God's signature in nature in a rational way? So here's what the Bible says. It says, He or God said in a loud voice, fear God, or actually the angel, fear God and give glory to Him, because the hour of judgment has come. Worship Him who made the heavens, the earth, the sea, and the springs of water. So this is God's claim to fame. This is God saying, this is the reason why you should worship me, because I made it all. I made everything, right? So you should worship me because of that. And who in particular of the Godhead made everything? Well, the Bible attributes it to Jesus. It says, in the beginning was the Word was with God, and the Word was God. He was with God in the beginning. Through Him all things were made. Without Him nothing was made that has been made. So that kind of covers it all, right? It was Jesus who made everything. And then I thought this was a strange verse for a long time. David says in Psalms, know that the Lord is God. It is He who's made us, and not we ourselves. Remember the children's story? Can we make ourselves? Well, there's quite a number of modern scientists and physicists who say yes. It's quantum theory. Ever heard of quantum theory? It's by observing something, you cause it to happen. So by observing the universe, we make it, and then the universe turns around and makes us. Right? All by itself, like we're drawing ourselves, sort of deal. And so David was kind of prophetic, I think, in this statement. He says, no, there's going to be people comes along, believe it or not, who says that they made themselves. And David said, that's not true. It's God who made us, not we ourselves. And I was like, it seems like an obvious statement. Hello, we didn't make ourselves. Like I didn't really make Wesley, right? I just pressed the launch button, so to speak. But we didn't make ourselves. And so David makes that clear. So this is going to be the 3-part series. The first one, of course, is the universe. And kind of the specialness of the universe. It was kind of made for us. This is just the right place, like Goldilocks. The story of Goldilocks. It's not too hot, it's not too cold. It's just right. So How is it just right? Well, according to modern science, it all started about 18 billion years ago with the Big Bang. And the Big Bang just started all by itself and popped out everything that we see around us today all by itself. No one directed it, it just kind of made itself. All starting from a singularity that's essentially nothing, and then it popped into something. Well, the Bible disagrees. David again, he says, the heavens declare the glory of God. The skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they display knowledge. There is no speech or language where their voice is not heard. Right? Everybody can go outside and look up at the stars. Everybody can go outside and look at the mountains. Lots of my friends are in Yosemite today. And that's just an amazing place. I don't know very many people who don't get a sense of awe and spirituality being in that place. And it doesn't matter what culture you're from, what language you speak, it speaks to everybody. David goes on to say, he determines the number of the stars and calls them each by name, which we'll soon find out is quite a spectacular feat. Calling them each by name, every star in the sky, God has a name for it. So how big is the universe? Just to get an idea about the magnitude of God. Now we're just talking about the visible universe. The universe is bigger than we can see. Even with our most powerful telescopes and radio telescopes, it's bigger than we can see. But what we can actually see is 92 billion light years in diameter. So if you have a balloon, it's 92 billion light years across, or it's 48.6 times 10 to the 26 meters in diameter. So that's just an extraordinary number. To get some idea, let's say we take a grain of sand and we make it the size of Mount Everest. And then we line up every grain of sand that size in a row, line them all up on planet Earth. Every grain of sand on planet Earth. Make it in the size of Mount Everest and line it up in a line. All these Mount Everests. That would be about the size of the universe in diameter. So, and that's just the visible universe. Estimates, by the way, a light year is 950 million kilometers. And estimates for the minimum size of the entire universe, go as high as 180 billion light years. So about twice as big. So there are around 1 times 10 to 22 grains of sand on Earth. It's around 10 billion trillion grains of sand. And there are at least 100 billion trillion stars in the visible universe. And recent arguments for 3 times that number. So there are at least 10 times as many stars than there are grains of sand on Earth in just the visible universe. So counting all the stars, or counting stars, let's say 10 stars a second, it would take 317 trillion years to count them all, if we counted 10 a second. So also as far as atoms, there's a lot of atoms. There's 1 times 10 to the 80th atoms in the visible universe. They're divided up into galaxies. There's 100 billion galaxies. Some argue for 1 trillion galaxies in the visible universe. And each galaxy has between 100 billion and 10 trillion stars in it. So an average of about 1 trillion stars per galaxy. The size of the planets, just to give you an idea of size again. Here's the planets in our little solar system as we kind of work on up to Earth. We're doing pretty good so far. The size of the Earth, we beat a few other planets. And then the Earth relative to the gaseous planets, it looks like a little marble, right? And then Jupiter compared to the Sun. And the Sun just dwarfs Jupiter, another little marble. But then there's bigger stars than the Sun. Sirius is bigger than the Sun by several fold. And then you look at Sirius, and it's a tiny little speck of nothing compared to Aldebaran, who's a giant star in our own Milky Way galaxy. All these stars I'm talking about here are just in our Milky Way galaxy. And Aldebaran is a tiny little pebble compared to Betelgeuse, which is in the constellation Orion, when you look up at Orion. Now, that star just dwarfs Aldebaran. And then there's bigger stars than that. There's Antares, also within the Milky Way galaxy, that's bigger than Betelgeuse. Antares is smaller than Cepheid. And then you compare Cepheid to Canis Majoris. Canis Majoris is the biggest known star in our Milky Way galaxy. And if you compare to the Sun, the Canis Majoris. It's just a tiny little speck compared to the largest known star just within our Milky Way galaxy. And then if you compare the galaxy to the biggest star in the galaxy, it just dwarfs the star. Right? So these sizes are enormous, we're talking about, for universal sizes. And so it kind of makes you think, what on earth is God thinking that he even thinks about us? He's got this entire universe to worry about, yet what is man that you are mindful of him, the Son of Man that you care for him? He actually cares about us. He sent his Son to die for us on a tiny little speck of a nothing planet in the middle of the universe, out in the middle of nowhere. So how much are you really worth without God telling you you're worth a lot? If you break yourself down, the average human body, size of a man, let's say a 180-pound person, into the basic component elemental parts, you got about 5 pounds of calcium, 1.5 pounds of phosphate, about 9 ounces of potassium, a little more than 6 ounces of sulfur and sodium, and a little more than an ounce of magnesium, and less than an ounce each of iron, copper, and iodine. Total value, about $5.60. All right? But before you feel too bad, the computer chip in my $1,000 laptop here, the component parts cost about 10 cents to make it. So where does the real value come from? The component parts or how they're arranged? Right? It's informational technology. Information is key. It's the new age, information age, right? Information is where the real value comes from, not from just the basic parts. So it's kind of how you're put together, and it's kind of how the universe is put together, where you get your value. But how else is value determined? Like, how much would you pay for this box of jewels and gold? Well, I guess it all depends on what culture you're in, right? For example, the second largest cut diamond now is the Cullinan 1. It's the Star of Africa. This is 530 carats in size. It's placed by King Edward on the royal scepter. It's part of the crown jewels. Its estimate value right now is over $400 million, but no one really knows because who's going to sell the crown jewels, right? So its weight is 3,106 carats uncut, the original weight of the diamond. It was cut into the great star, and then the lesser star, which is 317 carats, and then 104 other diamonds and of nearly flawless color and clarity. So this is about the most valuable originally uncut diamond there ever was. So, but why are diamonds so valuable? As far as precious stones are concerned, diamonds are one of the most common around. It's only because De Beers kind of, as a company, kind of hides them away and won't let everybody have access to them that they gain some value. You know, though, that I was thinking to myself when I was preparing this, I was like, I bet there is a planet that's a diamond. So I went to the internet and looked it up. Sure enough, there was this big star that collapsed. It was just the right size to only make carbon. And so when it collapsed into a diamond 5 times the size of planet Earth. So God has resources. You know, when you hear that when the Bible says God owns the cattle on 1,000 hills, well, that's kind of an underestimate, right? By a little bit. The carats for a diamond that size, 10 billion trillion carats. So, and it happens to be circulating around another star that shines, and so it glows as it goes. So it's a shiny diamond going around this other star. And so maybe it's an engagement ring for us when we finally get saved or something. Who knows, right? It's pretty cool, I think. So let's talk a little bit about the Goldilocks universe. It's made just right for us. This concept is called the anthropic principle. It was first proposed by Brandon Carter in 1974. He's from Cambridge University. It's delicate. He discovered several factors in his time. He discovered 38 features of the universe that had to be precisely balanced in order for complex life to exist, like us. By the end of 2001, astronomers had identified more than 150 finely tuned features characteristic of the universe that are necessary for complex life to exist. So a few examples. The universe is rapidly expanding. All the stars, everything that we see is moving away from each other. All the galaxies are moving away from each other. They're moving away at a precise speed. If they were moving away a little faster, the universe would expand too fast, and heavy metals and things would not be able to be produced. If it was going too slow, the universe would reverse this expansion pretty rapidly and crunch back down on itself. So it has to be expanding at just the right rate in order for things to exist as we know them. And this precision, the precision of expansion has to be accurate to 1 part in 10 to the power of 123. That's a tiny number. Again, there's about 10 to the 20th grains of sand in the Sahara Desert. So the odds of coming up with this number by chance would be like blindfolding yourself, throwing out a grain of sand, like writing my name on a grain of sand, really tiny, throwing it out in the Sahara Desert, and finding it 6 times in a row blindfolded. The same grain, mix it all up, go out and find it again. That's the odds that this would happen by random chance. Another feature, the galaxy. The Earth is just in the right space in the galaxy. You notice it's about 2/3 out from the center of the galaxy, and it's right between 2 arms of the galaxy. If it was a little closer to the middle, there's too much radiation in the middle of the galaxy. It would just fry everything on Earth. If it was too far out, there would be not enough heavy materials to create complex life. They have complex elements to create complex life. So it's just in the right distance from the center, and also it's in between 2 arms. If we were in one of the arms of the Milky Way galaxy, we wouldn't be able to see out. We wouldn't be able to study the universe like we do now. Because if when we're between the 2 arms, then we could get a nice view of the universe. We can see out. The solar system. Our distance, if our distance from Jupiter were any further, asteroids would hit us all the time. Instead, Jupiter acts like a big vacuum cleaner, and it sucks. Remember a few years ago, a bunch of asteroids went right into Jupiter like a string of pearls, right? Well, if Jupiter wasn't there, those things would just be flying berserk. It's the gravitational field of Jupiter that kind of vacuums up a lot of things that may hit us. The sun itself. If it were older or younger, the luminosity would not be sufficiently stable. It would fluctuate in its lightness and darkness. Also, if its mass was greater, the luminosity output from the star would not be sufficiently stable. Same with if it was less, it would be not stable enough. The mass also, if it was less, it wouldn't control tidal forces as well. The color, if it was redder or bluer, photosynthesis would not be as effective. The Earth, the surface gravity of the Earth. The planet's atmosphere, if it was stronger, would retain huge amounts of ammonia and methane, which would poison complex life. If it was weaker, the atmosphere would be lost because of the solar wind would blow it away. The distance from the sun. If it was a little bit farther away from the sun, like 1% farther, it would be too cold for water to cycle like as it does. If it was a little too close, a little closer, 1% again, it would be too warm for the stable water cycle to occur, kind of boil off. Rotational period. It needs to be about 24 hours, the rotational period of the Earth. If it was longer, there would be extreme changes in temperature from daytime to nighttime. In fact, on the moon, even without the atmosphere, it's very hot on one side and it's very cold on the other. If it was shorter, the atmospheric wind, because it would be spinning around faster, atmospheric wind would be greater. We get massive hurricanes, massive tidal actions, and it would just make things very complicated for complex life. Oxygen to nitrogen ratio in the atmosphere. If it were larger, life functions would proceed too quickly. It would be hard to slow things down as far as metabolic activity. If it was smaller, we'd be just kind of barely able to walk along. It has to be just the way it is for us to have the appropriate energy level. Ozone level in the atmosphere. If it was greater, surface temperatures would be too low. If it was less, there'd be too much radiation. The orbit of the Earth is nearly circular. The particular orbit of the Earth around the Sun is nearly circular, not exactly, but very nearly, more so than any of the other planets. If it was more elliptical, again, we would get extremes in temperature variation. If we were a little farther away and then a little closer, we'd get too hot and then too cold. The Moon is also just the right size and distance from the Earth to keep the oceans moving the appropriate amount so they don't get stale. Also, if the moon had greater gravitational effects, tidal effects would be too great, and we'd get these massive tidal waves swamping continents and stuff. That wouldn't be very good. The atom is very precisely created or balanced. Atomic charges. The proton and the electron, even though they have very different sizes and masses, they're precisely balanced as far as charge is concerned. If they were not precisely balanced to within a fraction of a degree or a percent, then complex molecules could not exist, and complex life, of course, could not exist. Also, the mass is important. The proton's mass is 1,836 times more massive than the electron. If it wasn't precise to that degree, again, complex molecules could not exist. So does anyone get it? Is this just a few handful of people who are on the fringes of society, you know? And what do some scientists think about this? Well, starting with some guys who are not alive anymore, Sir Isaac Newton, a pretty bright guy, came up with some, calculus and things like that, laws of gravity. He says, the most beautiful system of the sun, planets, and comets could only proceed from the counsel and dominion of an intelligent and powerful being. And Newton strongly believed that God was the creator of the universe. So what about some modern guys? Have we kind of abandoned this concept? Newton was kind of deranged on this particular idea. Here's a little video clip. Hopefully the sound will work.
The general view of this, for most physicists, is that these fine-tunings are largely accidental, that the constants of nature are determined by some mathematical principles which have nothing whatever to do with our existence. Impersonal, mathematical, and we were just incredibly lucky that mathematics happened to give rise to a universe with all this kind of fine-tuning.
For a while it was possible to believe that the laws of nature were not so precisely set as to require the hand of a creator. But then a completely new fundamental property of the universe was discovered. An anti-gravity force present in space itself. It is called the cosmological constant. And when cosmologists calculated its effect on the evolution of the universe, they realized it had to be very finely tuned indeed.
The fine-tunings, how fine-tuned are they? Most of them are 1% sort of things. In other words, if a thing is 1% different, everything is bad. And a physicist could say, maybe those are just luck. On the other hand, this cosmological constant is tuned to 1 part and 10 to the 120 decimal places. Nobody thinks that's accidental. That is not a reasonable idea, that something is tuned to 120 decimal places just by accident. That's the most extreme example of fine-tuning.
No force in the history of cosmology has ever been discovered to be that finely tuned. The cosmological constant needs to be set to 1 part in a trillion, that the cosmological constant arrived at such a tiny value by chance seemed to be out of the question. But the alternative explanation was also impossible to contemplate.
Physicists did not want to accept the idea that the laws of nature might be controlled by the benevolence of nature. There should be no reason why the luck should just have it that we can exist. It's too much, it's a stretch. It's much too far to stretch.
It seemed that hidden in the laws of nature was a value so precise that it was impossible to deny that our universe was designed. But a designed universe requires the existence of a designer, a notion that even the anthropic scientists did not want to entertain.
Interesting, right? Even people who are naturally predisposed to atheism and naturalistic concepts kind of get forced against their will to conclude that there's some hanky-panky going on, what's wrong? I mean, if you take all of the fine-tunings of the universe and add them all together, the precision necessary is 1 in 10 to the 500, 1 part in 10 to the 500 by random chance. So it starts to force people to think, hey, maybe something deliberate is going on here. What are the odds, right? So British mathematical physicist Sir Roger Penrose, he was among the first to voice the obvious philosophical conclusion. He says, the extremely high level of fine-tuning astronomers and physicists discern powerfully suggests purpose behind the universe. So this guy is a well-known mathematical physicist. Sir Frederick Hoyle, he's the man who coined the term Big Bang. He didn't believe in the Big Bang Theory, and so he liked to make fun of it by saying, oh, you guys who believe in the Big Bang. Right? Well, he is still a naturalist. He just believed that the universe was infinite in size. But anyway, the term stuck. In the early 1951, he argued that the fine-tuned features of universes were just coincidences. But a couple years later, he changed his mind and wrote, such properties seem to run through the fabric of the natural world like a thread of happy coincidences. But there are so many odd coincidences essential to life that some explanation seems required to account for them. A super intellect has monkeyed with physics as well as chemistry and biology. And he wrote this in a book called There Must Be a God. Australian astrophysicist Paul Davies argues, such stunning accuracy in the precisely balanced universe needed to support complex life is surely one of the great mysteries of cosmology. The belief that there is something behind it all is one that I personally share with, I suspect, a majority of physicists. I always thought physicists were smarter than biologists anyway. And even doctors, but never mind. That there must be a God who is responsible for these laws and responsible for the universe. And he actually uses the word God, which is a big step forward, I think. Owen Gingerich, professor of astronomy, University of Science at Harvard, senior astronomer at the Smithsonian, says, to me, belief in a final cause, a creator God, gives coherent understanding of why the universe seems so congenially designed for the existence of intelligent, self-reflective life. It would take only small changes in numerous physical constants to render the universe uninhabitable. Somehow, in the words of Freeman Dyson, this is a universe that knew we were coming. Right? And notice the title again, God's universe, right? Nobel laureate Arnold Penzias, he says, astronomy leads us to a unique event, a universe which was created out of nothing and delicately balanced to provide exactly the conditions required to support life. In the absence of an absurdly improbable accident, the observations of modern science seems to suggest and underline, one might say, a supernatural plan. So do we also believe the universe was made out of nothing? Yes. So we all get to the same end point, naturalists and creationists, we all get to the same end point, and then we say, well, is it turtles all the way up or turtles all the way down? Because we can't really go beyond this last hurdle here. And we say, well, it must be turtles all the way down, coming down from God. And they say, well, it must be turtles all the way up, coming up from random accident. Well, what do the odds really say? I mean, I have some land in, the swamp land in Louisiana to sell you. What are the odds? What are you willing to believe? Here's Freeman Dyson, who was quoted earlier. He's a mathematical physicist who says, as we look out into the universe and identify the many accidents of physics and astronomy that have worked out to our benefit, it almost seems as if the universe must, in some sense, have known that we were coming. Right? And he doesn't like it. He writes this in a paper called The Disturbing Universe. Right? Charles Hard Towns, winner of the Nobel Prize in Physics, UC Berkeley professor, he writes, this is a very special universe. It's remarkable that it came out just this way. If the laws of physics weren't just the way they are, we couldn't be here at all. Some scientists argue that, well, there's an enormous number of universes, and each one is a little different. This one just happened to turn out right. Right? Well, that's a postulate, and it's a pretty fantastic postulate. It assumes that there really are enormous numbers of universes, and that the laws could be different for each one of them. The other possibility is that ours was planned, and that's why it came out so specially. So the concept that there's multi-universes, multi-universe theory, is that a scientific idea? Is there any evidence for multiple universes to begin with? No. It's a philosophical necessity in order to try to avoid the otherwise obvious conclusion that there must be a designer. So this is just a battle of philosophies. It's not about a battle of science versus religion. So questioning God. Sometimes we're tempted to say when bad things happen to us, you know, I'm a good guy. I serve God. I pray. I study my Bible. I go to church. Why do bad things happen to me or my friends or my family? God's talking to Job here because Job said the same thing, right? Bad things happened to Job. Job was a good guy. Righteous, even God said so. God said Job was a good guy, righteous in his generation, right? So here's Job, God responding to Job's pity party. God says, where were you when I laid the foundations of the earth? Tell me if you understand. Who marked off its dimensions? Surely you know. Who stretched out a measuring line across it? On what were its footings set, or what were its cornerstones laid? While the morning stars sang together and all the angels shouted for joy. Surely you know, for you were already born. You have lived so many years. So like a little godly sarcasm there, right? You have lived so many years. So what's God trying to say to Job? God's putting Job in his place, right? You're a little tiny little speck, Job, right? So what do you have to complain about? All you really need to know is that I like you and I'm going to fix it for you, ultimately, right? That's all you really need to know. Leave everything else up to me, and because you really have no idea, right? So, again, our text for today, as the heavens are higher than the earth, so are my ways higher than your ways, and my thoughts higher than your thoughts. Which is a good thing, because God likes worms, right? He's going to fix it up for you. So it's kind of like a little story I heard a few weeks ago in church. It's kind of like, if anybody has little kids, I just have my little boy Wesley. Often, the little children want to help you, right? Daddy, can I help? Fix the food or set the table, and you're like, well, how many, dishes do I have left? And how much time do I have to clean up the kitchen after he helps me, right? And so it's similar to God. We go to God and we're like, in our prayers, you're like, God, let me help you, right? And God says, okay, because God actually wants us to ask to help, right? He wants us to be involved. But like this lady who was giving the sermon said, she's like, okay, you can help. And he whispers to the Holy Spirit and the angels. He's like, go back him up. He's going to make a mess, but make it all work out. So God lets us help because He likes to see us involved, right? He likes us like we're His little children. He likes us to want to help Him, to seek Him out, right? So, and then He says, don't worry about the trouble you're in. Don't worry about the problems that seem insurmountable. I've got it figured out. And He says, and I have plans. I have plans for you. He says, for I know the plans I have for you, declares the Lord, plans to prosper you and not to harm you, plans to give you hope and a future. So, do you want to make your own plans, or do you want to let God make your plans for you? I mean, how big do we think we are, right? So He says also, too, He's not going to forget about us. After all, Jesus came to die to save us, and He's going to bear these marks in His hands for eternity. And they remind Him of you and me, right? He says, see, I have engraven you on the palms of my hands. Your walls are ever before me. He says, Ellen White, this is an interesting concept. She says, one reminder alone will remain. Our Redeemer will ever bear the marks of His crucifixion, the only traces of the cruel work that sin has wrought. Through eternal ages, the wounds of Calvary will show forth His praise and declare His power. Just something to think about for the rest of the week.